today's goal of this lecture. Today I will see all statement of Schwarz lemma at first. Then I will see some application, some result, some question about this statement of Schwarz lemma. Statement, this proof I had seen in my previous video. Suppose fz is analytic for mod z less than r with the condition f0 equal to 0. That means here simple 0. If mod fz less than equal to m in mod z less than r, then mod f prime 0 less than equal to m over r and mod fz less than equal to m over r times mod z, where for all this condition hold for mod z less than r. And when the equality hold means f prime 0 equal to m over r, fz equal to m over r times mod z. When the equality holds, then fz equal to m over r times e to the power alpha z, where alpha is a real number. And another statement, f from D to D holomorphic function. F be a mapping from dix to dix, D to D, such that f of 0 equal to 0. Here Schwarz lemma always applicable when f of 0 equal to 0. If f of 0 equal to 0, then mod fz always less than equal to, by Schwarz lemma we can tell mod fz always less than equal to mod z and mod f prime 0 less than equal to 1. Here notice this Schwarz lemma, when fz less than equal to m in mod z less than r, then fz equal to m over r times mod z. Here since the function defined this dix to dix and here 0 map to 0, then since here dix to dix, so mod z less than r means here mod z less than 1 and fz also since dix to dix, so this would be less than 1. So here m equal to r equal to 1. So obviously if m equal to 1 and r equal to 1, then f prime 0 less than equal to 1 and fz would be less than equal to mod z. So here fz less than equal to mod z for all z belongs to domain and f prime 0 less than equal to 1. And when equality holds at some points z not equal to 0, if and only if fz equal to e to the power I theta times z, where f is a rotation. I hope my all viewers have understood clearly. Okay, oh well. Corollary of Schwarz lemma, let fz is analytic for mod z less than r with the condition f0 equal to f prime 0 equal to f n minus 1 0 equal to 0. That means f has 0 of order n. If mod fz less than m less than equal to m in mod z less than r, then here extension is here 0 of order n. Previously I had seen always simple 0 exist, but here 0 of order n. Then fz would be less than equal to mod z over r to the power n times m. If mod fz less than equal to m in mod z less than r, then this condition hold. And with equality only for fz equal to m over r to the power n e to the power I alpha times z to the power n. Here also one thing would be added. here fn0 over n factorial less than equal to m over r to the power n, and this is true for all mod z less than r. Okay, actually extension of Schwarz lemma. In Schwarz lemma, many of the function defined on disc to disc. So if a function such that fz is analytic on the disc z such that mod z less than 1, then obviously modulus of fz would be less than equal to 1. This is true for all z belongs to D. And fm0 equal to 0, that means fz has a 0 of order m. Then that implies, since here the value of m, since fz equal to 1, that means less than equal to a value of m equal to 1, and since mod z less than 1, so r equal to also 1. So fm0 less than equal to m factorial and modulus of fn0 and modulus of fz less than equal to mod z to the power m, and this is true always mod z less than 1. Okay, this is actually the extension of Schwarz lemma. Actually this is more applicable because here m equal to and r equal to 1, this is more applicable. Now I will see what is the Schwarz peak lemma. I had discussed this part elaborately in my previous video. Today just I have defined the statement only as for review. If fz is Schwarz peak lemma is, if fz is analytic in mod z less than 1, then f prime fz less than equal to 1 minus mod fz whole square divided by 1 minus z mod z square. Here if f of a is given, then we have to prove f dash a is what, and modulus of fz less than equal to f0 plus mod z divided by 1 plus mod f0 times mod z. That means if f0 given, then what is the value of f of a? Next question, let f be a function from D to D closure, means open disc to closed disc with radius 1. In the condition f0 equal to 0, since f0 equal to 0, so we can apply here the Schwarz lemma, where D is the open disc and D closure is the closure of the disc. First, f of 1/2 less than equal to half. Obviously, since here f be mapping from D to D closure, so always fz less than equal to 1. That means here m equal to 1, also here mod z less than equal to 1. That means here r equal to also 1. So modulus of fz less than equal to modulus of z. So notice option 1, f of modulus of f of half less than equal to modulus of half. Obviously if we put half, then f of half mod f of half less than equal to mod half. So option 1 is a right option. F of half less than equal to 3/4 mod 3/4, this is wrong. Here double derivative of f double prime 0 less than equal to 2 and f double prime 0 less than equal to 3. Here I have seen fn0 over n factorial less than equal to m over r to the power n. That means since here m and r equal to 1, so fn0 would be less than equal to n factorial. That means here about f double dash 0, l double dash 0 would be less than equal to 2 factorial. So 2 factorial means 2. So option 3 also right option. Option 4 is a wrong option. Next, consider f be a function D to D, where D is a open disc and condition f0 equal to 0. Since f0 is equal to 0, so here we can apply the Schwarz lemma. Then option 1, f prime 0, absolute value of f prime 0 equal to 1. Option 2, f of half less than equal to half. Option C, f of half less than equal to 1/4 and f prime 0 less than equal to half. F prime 0 less than equal to 1 minus absolute value of f0 whole square minus 1 minus 0 square. This is less than equal to 1 minus 0 divided by 1 minus 0. This is less than equal to 1. Here given f prime 0 less than equal to 1. Here given f prime 0 less than equal to half. Or f prime 0 less than equal to 1. And notice here f prime 0 less than equal to half. Half less than equal to 1. This is possible. So option D is correct. And option A imply modulus of f prime 0 equal to 1. Assume let D be a open disk in complex plane, and if f be a function from D to D closure be an analytic function with the condition f of 0 equal to f of 0, then we can apply the Schwarz lemma. By Schwarz lemma, modulus of fz less than equal to z and f prime 0 less than equal to 1. And if the equality hold, modulus of fz equal to mod z, or if z not equal to 0, f prime 0 equal to 1, then fz equal to always az with modulus of a equal to 1. If we consider, that means since here f prime 0 equal to 1, that means since the equality, that means fz would be such type, az type, then f prime z would be a. And let us assume f prime 0 equal to 0.7. That means here f prime 0 equal to a equal to 0.7. Therefore a equal to 0.7. Therefore fz equal to 0.7 a. Here given f prime 0 equal to 1, but if we consider a equal to 0.7, then f prime 0 equal to 0.7, which is not equal to 1. Here I have done one thing, printing mistake. This would be, since value is 0.7, so this is would be z, fz equal to 0.7 z. So since f prime 0 equal to a, so this value is 0.7. I hope my all viewers have understood clearly. This is my printing mistake. So option A is not true, and option B, absolute value of f of half less than equal to half. Notice f of half less than equal to, since given f of 0 equal to 0, f of 0 plus modulus of f of 0 plus modulus of z divided by 1 plus f of 0 times mod z. And here f of 0, equal to 0, so this value is 0, mod z equal to half, that means the plus half, divided by 1 plus 0 times half, this is less than equal to half. That means f of half would be less than equal to half. F of z less than f of half would be less than equal to half. But here given f of half less than equal to 1/4. This is not true. Next question, which had come CSIR NET June 2023 exam. The question is, let f from z such that mod z less than 1 to z such that mod z less than equal to half be a holomorphic function such that f of 0 equal to 0. Since f of 0 equal to 0, so we can apply Schwarz lemma. Then which of the following statement is true? Option 1, modulus of fz less than equal to modulus of z, and this is true for all z in such that mod z less than 1. F of z less than equal to mod z over 2 for all z in z belongs to mod z less than 1. Option 3, f of z less than equal to half for all z in z such that mod z less than 1. And option 4, it is possible that f of half equal to half. Since f be a mapping from z mod z less than 1 to z such that mod z less than half less than equal to half. So fz belongs to z such that mod z less than equal to half, and this is true for all z belongs to z such that mod z less than 1. Okay, so option 3 is a right option. And option 2, mod fz less than equal to mod z over 2. Is it true option? Notice Schwarz lemma. If mod fz less than equal to m in mod z less than r, then modulus of fz less than equal to m over r times mod z. This is true for all mod z less than r. Here, since modulus of fz, here I have got modulus of fz always less than equal to half. That means m equal to here half. And this is true for all mod z less than 1. So r equal to 1. That means fz, modulus of fz would be here r equal to 1, m equal to half. That means mod z over 2. And this is true for mod z less than 1. This modulus of fz less than equal to m mod z over r. This is true for mod z less than r. Since here m equal to half and r equal to 1, so this would be m half mod z. This is true for mod z less than 1. So option 2 also right option. And since this is less than equal to mod z over 2, which is mod z less than 1, that means this is also true for mod z. So option 1 also right option. And option 4, it is possible f of half equal to half. Since here I have got mod fz less than equal to mod z over 2, and this is true for all z such that mod z less than 1. That means f of half would be less than equal to half over half, and this is less than equal to 1 over 4. So it is possible that f of half equal to half. This is wrong option. That means option 1, option 2 and option 3 are right option. Next question, which had come CSIR NET 2020 to 2020 exam. The question is, d equal to z belongs to c such that mod z less than 1 be appendix such that f be a mapping from d to d be a holomorphic function such that f0 equal to 0 and which is equal to f prime 0 equal to 0. That means here 0 of order 2 Then which of the following value of f of half? We all of us know it has n ordered zeros. If fz less than equal to m, then modulus of fz would be less than equal to mod z to the power over r to the power n times m, and fn 0 over n factorial less than equal to m over r to the power n. Since here function defined d to d, that means here r equal to 1 and here fz would be less than equal to 1. Since fz would be less than equal to 1, that means the value of m also equal to 1. And since here 0 of order n, so this value n, the value of n equal to 2. That means modulus of fz would be less than equal to mod z to the power n. Then what is the value of f of half? The value of f of half less than equal to, here n equal to 2 less than equal to 1/4. So the value of f of half equal to 1/4. I hope my all viewers have understood this is okay. Well, today I will stop here. In my next video I will discuss removable singularity. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.